Welcome to the Deep Dive. This is the show where we take your sources, dig into them, and pull out the most fascinating insights, basically giving you the shortcut to being really well informed. Today, we are plunging into a topic that's, well, it's not just shaping our future, it's actively transforming our present. Artificial intelligence. And we've got quite a stack of material here. I mean, everything from historical entries, encyclopedic stuff, to deep dives into ethical criticisms, real-world applications, and, yeah, even AI's sometimes wild presence in pop culture. Yeah. So our mission for this deep dive is to unpack what AI actually is, where it came from, what it's doing right now, and importantly, the pretty profound questions it raises for all of us.
Yeah, and it's striking, isn't it, how broad the definition of artificial intelligence can actually be. At its core, it's often described as these efforts, real or imagined, to simulate human cognition, human creativity, distinguishing machine and code from, well, the natural intelligence of animals and people.
Okay, let's unpack that definition for a second, because I think it really sets the stage for everything else. One of the early AI pioneers, Herbert, he noted something really interesting. That while natural things, rocks falling, planets orbiting, they have this air of necessity, they follow physical laws.
Yeah.
Artificial phenomena, things we build, they possess an air of contingency. They're malleable, we can shape them. Essentially, he thought humans are great at adding complexity to their environment, and Simon reasoned the way forward is to create more of this artificial world. You might almost think of the brain as a natural computer, and the mind, well, the mind is a kind of human-made computer program.
Exactly. And that idea connects to the bigger picture, right? The journey of AI, it really began with some foundational discussions. Like the Macy conferences started way back in 1946. They explored feedback mechanisms and circular causal systems in biological and social systems. Sounds technical, but it was laying early groundwork.
Okay, feedback mechanisms. And here's where it gets really interesting, I think. Just a decade later, 1956, we get what people often call the Constitutional Convention of AI, the Dartmouth Summer Research Project on Artificial Intelligence. This was huge. An interdisciplinary conference brought together giants like Claude Shannon, Marvin Minsky, John McCarthy, who, by the way, actually coined the term artificial intelligence just the year before. And their rallying cry was incredibly bold. Listen to this. Every aspect of learning or any other feature of intelligence can, in principle, be so precisely described that a machine can be made to simulate it.
Wow.
Imagine saying that in 56. It really set the ambition for the whole field. So what were some of the first actual attempts to simulate intelligence that came out of that period? Well, yeah, a really notable early example was ELIZA. It was a conversational computer program developed by Joseph Weizenbaum at MIT. This was between 64 and 66. ELIZA was designed for human interaction using plain English, and it kind of mimicked the psychotherapist. And what's wild? ELIZA got so popular that its creator, Weizenbaum, actually became an AI skeptic because of it.
Huh. That's fascinating. And that skepticism, it definitely continued. You see it with Hubert Dreyfus. In 1965, Rand hired Dreyfus to assess AI prospects. Now you had optimists like Herbert and Marvin Minsky predicting machines doing anything humans could within decades. But Dreyfus argued that AI's theory was based on this flawed philosophy of human psychology, associationism, basically just linking ideas. He felt it totally missed human stuff like fringe consciousness, that background awareness, insight, our tolerance for ambiguity. He later wrote the book What Computers Can't Do in '72.
A really important counterpoint to all that early hype. Yeah. And we can't forget the groundbreaking work on expert systems like MYCIN in the early 70s. Developed at Stanford, MYCIN was designed to help doctors diagnose infectious diseases, recommend antibiotics. Yeah. And what was really cool was it could even provide explanations for its deductions. You could ask it why. Mm-hmm. So, okay, fast forward. What does all this foundational stuff mean for us today? The advancements since then are just mind-boggling. Let's talk about deep learning. This is allowing machines to classify patterns using neural networks.
We're essentially learning by example.
Yeah, exactly. Learning by example. And what's fascinating is how it's applied now. Deep learning is in automated driving, medical diagnosis, image recognition, text recognition. It's everywhere. Think about Chexpert from Stanford and Intermountain Healthcare, diagnosing pneumonia from x-rays in just 10 seconds. 10 seconds. That's incredible speed. And it's not just diagnosis, is it? Natural language processing. NLP, programming computers to analyze, recognize natural language. Think about predictive text on your phone, speech understanding, those chatbots you sometimes talk to online. Microsoft's Lily Chang, for instance, her focus is on making AI tools trusted, protecting user privacy, enabling really seamless human-like conversations.
Which raises an important question. How does this stuff manifest in the physical world? I mean, we see robots much more now. Rodney Brooks, for example, famous for behavior-based robotics and, his company's iRobot Roomba vacuums. But his company also created the PackBot, which was used for detecting and diffusing explosives in Iraq and Afghanistan. Really serious applications.
Definitely serious. And speaking of physical applications, AI is just revolutionizing transportation. Driverless cars, trucks, moving from semi-autonomous to conditionally autonomous. That's where the human can kind of exit the loop of control, and eventually fully autonomous systems. Tesla, co-founded by Elon Musk, obviously a huge player, relying heavily on cameras, radar, ultrasonic sensors instead of LiDAR, which is another approach using lasers.
Yeah, and if we connect this to the bigger picture, intelligent transportation systems, like Carnegie Mellon's SurTrack for traffic control. These systems can significantly cut travel times, fuel consumption, just by optimizing stoplight timing. That has real implications for climate change, too.
It's not just about efficiency, though, is it? AI is getting incredibly creative now. We're talking about computational creativity.
It's fascinating how it's evolved. Herbert Simon, back in 1958, he actually predicted computers would write music accepted by critics within 10 years. And look at David Coates' experiments in musical intelligence, EMI. It analyzes existing music and generates new scores, apparently indistinguishable from Mozart or Bach.
Yeah.
And in visual arts, you've got the painting fool, an automated painter. And that collective, obvious, they used generative adversarial networks, GANs, to create the portrait of Edmund Bellamy.
Right, the one that sold for nearly $500,000 at Christie's. That's a serious art market driven by algorithms.
Right.
We also see AI in specialized medical apps, like automated multiphasic health testing, AMHT, that was back in the 50s, using IBM computers to crunch patient data. And out in the field, Tanya Bergerwolf uses AI algorithms to identify individual Grivy's zebras for conservation. Amazing stuff.
It really shows the breadth. But beyond the helpful applications, how else is AI being deployed? It's also changing the military battlefield. Lethal autonomous weapons systems, or LAWs. These are armaments programmed to select and engage targets without continuous human input.
Yeah, that's a concept that's, frankly, pretty terrifying for a lot of people. And it's led to serious ethical debates. Human Rights Watch launched the Stop Killer Robots campaign back in 2013, calling for global prohibitions. But military strategists also point to potential advantages, like increased force projection, maybe saving human lives by reducing the number of combatants needed.
Oh, yeah.
It's complex.
It really is complex. And despite all these impressive capabilities, AI faces some pretty significant criticisms. Adaptability is a big one. Computers excel at limited tasks, right? But it's much harder to teach them to adapt to unforeseen situations or to understand causation, why something happens, which is so integral to human intelligence. This is often called the black box problem of AI. Even the designers sometimes can't fully explain how complex, deep learning algorithms make their decisions. And that's where explainable AI, XAI, comes in. The whole goal is to get outputs that humans can actually understand and trust.
Right, because that black box can definitely hide some serious issues, like bias. We're seeing algorithmic bias crop up all over, like those examples from Facebook's targeted job ads, where janitor positions were shown mostly to lower income groups and minorities, and nurse positions mostly to women.
Exactly. It shows how biased data, the stuff we feed these systems, can introduce discriminatory discrepancies into the machine's predictions. And it's not just advertising. Think about predictive policing software like Predpol. Used by over 60 U.S. police departments, concerns have been raised about its accuracy and the potential for bias in identifying crime hotspots.
And the bias isn't just in the data, is it? It can be encoded into the AI systems themselves, even reflecting things like gender norms. Our sources point out that computer engineers, still mostly male, tend to create a disproportionate number of female robots. There's an example. Jia, a human-looking robot from China, who apparently keeps her head tilted down, like in deference, and asks, "Yes, my lord, what can I do for you?" You see this bias in pop culture too, right? The whole fembot trope in films and music videos.
Definitely. And beyond bias, the philosophical questions are just huge. People tend to humanize robots, or they fear they'll become too human-like. The whole concept of personhood for AI is a massive debate. Opponents argue, look, they're human-made property. They lack will, a soul, feelings, consciousness. The famous mirror test for self-recognition passed by some animals gets brought up. But critics argue, well, that test really privileges vision. Maybe there are other forms of awareness.
That's a good point about the mirror test.
Oh.
But what does this all mean for some of the more out there ideas like digital immortality? Transferring your mind into a machine.
Well, scientists like Kenneth D. Miller, they're pretty skeptical. They suggest reconstructing a truly functioning mind is probably centuries away, if even possible. And, maybe identity is more than just the sum of neuron relationships anyway.
Right. Which leads to the really big question about control, doesn't it?
Absolutely. It's the great paradox of AI, isn't it? It has this massive potential to maximize our preferences, make life better, but at the same time, it could make us vulnerable to global catastrophes, even existential risks.
Yeah.
Nick Bostrom, for example, he argues that a poorly programmed superintelligence could even exhibit psychopathic behaviors unintentionally. He calls for really careful crafting of friendly AI that learns human values.
And you hear echoes of that from people like Elon Musk, right, a co-founder of OpenAI. Their stated goal is developing and promoting friendly AI that benefits all of humanity, keeping it open, available to everyone to try and minimize the potential dangers if it gets concentrated in too few hands.
Yeah, and connecting this to the bigger picture, the potential for job displacement is a huge concern for society. Author Martin Ford, in his book Rise of the Robots, really emphasizes this. Autonomous cars, self-checkout, food prep robots, they're going to profoundly impact the workforce. And it's not just blue-collar jobs. He argues it'll affect white-collar jobs, too, and that maybe there won't be a clear relationship between education level and vulnerability to automation anymore. That's a big shift.
A massive shift. And then there's the question of liability. Who's responsible when things go wrong? With driverless cars, you've got those 5 levels of automation. At levels 1 to 3, where there's still human-machine interaction, maybe the manufacturer is liable if the car didn't communicate properly with the driver. But at levels 4 and 5, fully autonomous, then it looks more like product liability for a defective product. And that raises the even bigger question. Could the AI itself eventually become a legal person responsible for compensating victims?
Wild stuff to think about. It really is. And it speaks to the unpredictability of advanced AI. Since these systems operate by adjusting and interacting with their environment, with users, the results of changes can be unpredictable, potentially even catastrophic.
So beyond all the technical stuff, the ethical debates, AI has just captured our imaginations for decades, hasn't it?
Oh, absolutely. What's fascinating is how science fiction has been exploring these exact concepts for so long. Ex Machina from 2014 is a great recent example.
Yeah.
A scientist tries to create a self-aware female android. She escapes. It really challenges the audience to see her humanity. It's basically recasting themes from Mary Shelley's Frankenstein, creation, responsibility, what it means to be human.
Yeah, you definitely see that. And you see AI's lighter side, too, like in the Jetsons with Rosie the Robot Housekeeper. Fun stuff. But then, yeah, the darker implications, those autonomous weapon systems we talked about, they aren't quite Terminators yet, but they're lethal enough to inspire campaigns to stop them. And the film The Terminator, 1984, that really crystallized that fear, didn't it? Skynet, the military AI, becoming self-aware, waging war on humanity. It tapped into a deep anxiety.
For sure. And you can't talk about AI in fiction without mentioning Isaac Asimov's Robot series, starting back in the 50s. He gave us his famous 3 laws of robotics. Robot can't injure a human, must obey humans, must protect itself, with the earlier laws taking precedence. He even added a 0th law, later protect humanity as a whole. But while they're cited all the time, people also criticize them as being, well, insufficient, impractical for a real-world moral code.
Still influential, though. We've also seen AI in narratives like the film Her from 2013. That explored a romance between a man and his AI assistant, Samantha. Really complex emotional territory. And the TV show Person of Interest dramatized a lot of these ethical questions. The creator, Finch, trying to program the machine with the right values, especially preserving human life. These stories make us think.
They really do. And this raises maybe the most speculative question. What about, spiritual robots? It sounds strange, but there are examples, like that mechanical monk commissioned by Philip II of Spain in the 1560s. Or, more recently, Santo, billed as the first Catholic robot, and a Protestant one called Bless You Too. And some new religions, like the Church of Perpetual Life, they actually embrace transhumanism, technologies like mind uploading. It shows how deeply these ideas are starting to penetrate.
Wow. Okay, we have taken a real deep dive today from the very earliest ideas about AI right through to its current incredibly multifaceted applications and these profound ethical and societal questions it's forcing us to ask. We've seen how AI isn't just, algorithms and machines. It's kind of a mirror reflecting our hopes, our fears, even our own biases back at us.
Yeah, and if we connect that back to the bigger picture, that paradox is key. Artificial intelligence is maximizing our preferences, making things easier, but simultaneously, it's making us vulnerable to potentially huge risks. It's fueling this reinvention of ourselves in a new computational universe, and it engenders this full range of emotions, right? From total euphoria and excitement to deep anxiety, maybe even misery.
So what does this all mean for you listening to this? As you navigate a world where AI is just advancing incredibly quickly, it's worth remembering what Mark Andreessen famously said back in 2011. Software is eating the world. And as we've really explored today, AI is increasingly the engine driving that software. It's everywhere. So consider this. If machines can create music that fools experts, if they can develop empathy in therapy, if they can even inspire new religions, what unique aspects of human intelligence, human consciousness will truly define us in a future we share with these increasingly capable artificial minds? And maybe more importantly, how will you choose to engage with this evolving intelligence? Something to think about.